This is the second lesson on continuous random variables. I forgot to video as I did it, so I'm just going to put a commentary here to go with the notes. So if you can print the notes out, that might be helpful. First thing we did was just recapped what the key things were from continuous random variables from the previous lesson. So the area under the curve was 1, and that signifies the total probability. The probability of x taking any specific value was 0 because it was continuous. We had to look at ranges of values. The function is always greater than or equal to 0, and to work out the probability between 2 points, you integrate your function between those values. We then said we'll consider the median and how we could find the median of a continuous random variable. We just drew a little sketch of our function. It existed between a and b, and the median is the middle. Now it's not halfway between a and b, it's the point at which half the area is to the left and half the area is to the right. That's what the median is. So we said, how would we find that out? We'll be integrating our curve, our function, and we want the area to be equal to a half. And we start from our lower limit and go up to our median, which we don't know what that is. That will be satisfied. So we always have to solve this equation here. We integrate from our lower limit up to our unknown m of our function, and if the answer is a half, we solve that to find out what m is. So we did an example. We had a function. First of all, we had to find out what a was. Then we were going to find out the median. Then we were going to find the probability. So part A, if you've got to find the constant, that's when you use the fact that the integral of the whole thing is 1. So we wrote out our function. The limits here are 0 and 1, and I knew the area equaled 1. So I integrated it, worked out that a was equal to 4. Then I wrote out my function again, but now not with a in there, but with 4 in there. So the next thing was finding the median. So I've integrated between 0 and m my function, and I've put the answer equal to a half. So I've integrated my function. That shouldn't be there down there, that's just scribbling out. Integrate my function. That bit there is the same as 2x squared. And continue through the integration. I get this equation here with an m to the power of 4 in it, which I didn't like, so we wrote the word there, not very nice at all. And we discussed how to solve that. Well, that's a quartic equation. It's got a squared in and a power of 4 in it. Well, if you create some other sort of variable to help you out, let's call it t, and I let every m squared be replaced by a t, this becomes 2t, take away t squared equals a half, which is a quadratic. And you can play around with that quadratic, you can rearrange it so everything's positive, you can get rid of the fractions if you want to, you could use the quadratic formula, or you could type it straight into your calculator and you will be able to solve it to find out what t is. But then remember, t is what m squared is, so to get m you need to square root that, and you will end up with that answer. So we said we just looked at the, we're still one more part of that question to do. That was find the probability it lies between 0.1 and 0.6. To find the probability in a range, you integrate your function between those two limits. We've already done the integration. We put those limits in, and we get an answer. It came from, when you put 0.6 in, you got that. Put 0.1 in, you got that. Do the taking away, you got that one over there. So we said, okay, what about finding the mode? Well, the mode is the most common, and in a continuous random variable distribution, the mode is the maximum value of the function. So, okay, how do we find the maximum value, or otherwise the highest point of the function? Well, that's just finding a maximum. So you differentiate it and you put it equal to 0. So we had our function, we differentiated it, put it equal to 0, solve the equation, we have x is 1 over root 3. We had that as a decimal as well. That was how we would find the mode. So we've done so far today the median, and we've done the mode. So the next thing we're going to look at is finding the mean. So finding the mean, you knew how to do this with a discrete random variable. If For example, if you had a table like this, different values and probability to go with each one, you would have known from S1 how to find the mean. To find the mean, you timed each probability by its x value and added them up. That's how you did it in a discrete thing. If you're going to do it as a continuous distribution, instead of adding up, you'll be integrating. P, which is representing your probability, becomes your function f of x. X remains the same. If you're integrating, you need the dx there at the end. So for a continuous random variable called x, the mean, which we often denote as e of x, the expectation of x, is the integral between your limits. So for the sort of red box rule, we put minus infinity to infinity. You'll change those to your specific numbers in the example. And the x is times by f of x. That's what you're integrating. Then we said, okay, what about the variance? Well, when it was discrete, you had the sum of x, each x value squared times by the probability, take away the mean squared. This was often called the expectation of x squared. This over here is the expectation of x all squared. You have to be careful about that. So we said, well, it's the same formula for continuous. We just need to work out how to work this expectation of x squared out. Here it is. All we have done is just mapped along from here. The summation becomes the integral. X squared stays in there. The probability is now f of x. So the expectation of x squared is the integral of x squared f of x. And then we can just stick that in there. The mean we already have worked out from here. And you've got your formula for the variance. So we've now done the mean and the variance. The standard deviation is still the square root of the variance. So we had an example. An example here, first of all, find k, then the mean and the variance. Well, we could have found k by integrating the function, setting it equal to 1, but we said, hang on, if we just do a sketch, what shape are we going to get here? And that's a straight line. And we know, if we do that sketch, when x is 0, the value of the function is 0, and when x is 1, this will be k times by 1, which is k. So actually we have that line here, 0, 0, down here, it's supposed to be going through, and this is the point 1k. So we end up with this shape here, but we know the area under that curve is 1, which is what we have written down here. But it's just a triangle, width is 1, height is k, area, base times height divided by 2. We know the area is 1, and from there you can work out the value of k. K is equal to 2. So we now have our function. So to find the mean, which was the next bit, or the expectation of x, we integrate our function times by x. So if I times that by x, I get 2x squared. And I'm integrating that between the limits that are provided in this question. I do my integral, I stick my limits in, and I get my answer. And for the variance, I use the formula, it's the expectation of x squared, take away the expectation of its x all squared. This one then is the integral of my function times by x squared. So instead of being 2x times by x squared is 2x cubed. Integrate that between the limits, put the values in, and you get your answer out. So it will be this one, take away that one squared, which gives me my variance. And that came out to be 1/18.